I hope you still remember all the acronyms that I taught you before for curved mirror, especially the concave mirror. Actually, the rules apply here as well. So if you still remember what I mentioned about far rate, far means it can be really far away, infinity, and it can be really quite far, more than 2f. More than 2f is considered quite far also. So what we have here is that if you have f here and 2f here, f here, 2f here, for this image is standing here. But as for this one comes from infinity. Coming from infinity, perhaps I should draw the ray like this. I'm gonna use blue. And the ray from far away, maybe I'll just use a very common ray that passes through the optical center. Passing through the optical center is not really a problem. And then the other one passing through the F. These two rays must be parallel because they are coming very far away. Okay, so this ray number 1, ray number 2. Ray number 1 passing through the optical center, unrefracted. Ray number 2 coming and strike the F, it will come out parallel with the principal axis on the other side. So you should be able to get an image here, which is real, inverted. Real means if you put a projection screen there, you put a screen there, the image can be formed. Real, inverted, and diminished. That's why you have far rate. Or you can use far-risk also, because S means small, far-risk. Okay? So we just use diminished here, far rate. Diminished is getting smaller. So the image is formed here. On the other hand, let's use blue again. On the other hand, we have this one. The arrow is standing more than 2f away from the lens. So the object distance, let's try the parallel ray first. It will come out striking F. Okay, let's draw it properly, a bit off. Striking F seems like a good estimation based on this and that. So coming down, and the other one should be striking the F and coming out. Okay, so the intersection of these 2 points is somewhere in between. Okay, my drawing not good, but if you measure it properly, you should be able to get an image which is formed between F and 2F, which is here. Okay, you get V between F and 2F, U more than 2F. Okay, U stands for the object distance, which is here. V stands for the image distance, which is around here. Okay, so the next thing we need to know is we are done with far rate, so let's go to something else. Remember the same size guy? The same size guy shouldn't be a problem to you because you know that F is here, 2F is here. If your arrow is here, okay, let's try our hands. If it is parallel, it will strike F. Okay, F is more or less here. And then if you strike F, you come up parallel. Okay, so your image here, and this point is 2f estimated. You can check by drawing actual measurement. And your image, let's use blue to represent the image and the object. Blue is here and blue is here. Okay, so it seems like U is 2f and V is 2f. And this is what we call a real image. Is it inverted? Yes. Is it same size? Yes. Same size as in same height. This height of the object is the same as height of the image here in terms of the value. So we have Ri same. Ri same size, or you can say same height. How about the middleman? The middleman is really interesting because we know that F and 2F, if you stand in the middle, you have the word M, the red M, and this M will give us an indication that the image form will be real, inverted, and magnified. Okay, how do we prove that? Let's find out. If this one is parallel, it will strike F. If this one is strike F, okay, drawing not good. Okay, let's draw again to rectify my mistake. Okay, so we have this more or less correct. I'm trying my best. So it seems this one should be more than 2F, so let me readjust the 2F again. Should be here. So your final image is more than 2F already. Proven by measurement. If you use graph paper to draw them, you should be able to get the final answer like this. So your final image is actually more than 2F. If you are in the middle, this one is the middle guy. So the image is actually real, inverted and magnified. Real, inverted and magnified.